Well, I'm very glad that we are here, and I'm very glad that we can have this conversation. And I apologize for the fact that I have been given, that's called corrective discrimination or something, positive discrimination. I've been given 40 minutes, whereas the others have only 20 minutes. The reason I was given 20 minutes in addition is probably due to the fact that I came from far away, and that's a compensation for that. But the point is that also in prolongation of the symposium, where I had to give a general talk for a general public, in 40 minutes, it was mission impossible because I guess that everybody remembers the title of the symposium and the title of my talk. So to speak about uncertainty, complexity, artificial intelligence in front of a public who is not the public which is here today in general, then it was indeed mission impossible. So I asked for 40 minutes also because what I'm trying to do here is not only to talk to the general public and to specialists, colleagues in physics and other disciplines. I'm here also to try to set up a research activity, which hopefully it will be an international research activity. And again, everybody is looking for international research activities because they are prestigious, because they can bring in money for research and so on. I think that it has to be international also because we have to get inputs from very different cultural areas. Even if we are physicists and philosophers and we have well-defined disciplines in which we were educated and which we work, we need to listen because by its very essence, artificial intelligence, to begin with, has to do with the words which you use, with the constructs we build, intellectual constructs we build with these words. And then there is a big issue of the, excuse me, I have a cold and I have to drink all the time. What I said is that we have to be careful. How do we build this new way of thinking? I will try to avoid all the time today the word paradigm, roughly for the reason you mentioned, because it's very difficult. If I would have now 40 minutes to comment things which you put on this view graph only, and if we would have gone into the story of what were the problems, I think in the next view graph or in the first view graph, you mentioned restricted the relativity, the first version of the relativity, and the discussions which took place between 1905 and 10 years later, when Einstein came up with the general relativity. There was a lot of discussion going in there. There was change in paradigm back and forth. And by the way, change in paradigm and ways in which you invent new things. Think of Boltzmann. This poor guy dared to think differently and paid with his life because he committed suicide because everybody said this guy is crazy. what is he talking to us now about atoms and molecules and statistical mechanics, I call it now, but is it okay? Oh, no. Yeah.
This is better.
Is it better now? Yeah, I think it's better. All right. So Boltzmann went in a completely new direction. And everybody said the guy is crazy. What? How did we define entropy? With concepts which we understood very well. So now he comes and talks to me about distributions and statistics and all this stuff. That could be called also a change of paradigm. And that came, and here I'm going to jump a little bit from concepts to concepts, not because I want to drop all kind of concepts and things, because that's the shortest way. I'm going to go like a molecule in this article which Einstein wrote. I was very impressed that Einstein wrote this article about basically, which was also important for statistical mechanics later on, and which has nothing to do with relativity and gravitation. But the point is that I will go from one interaction to another interaction on a short path. So I will use sometimes a concept or a syntagm just to launch an idea. So the problem is that we have to very much concentrate on the meaning of all these expressions which we use. And indeed, you notice that somebody coming from outside the field, he had this question about this discomfort with what is machine learning. You say there, what is that's ML physics. Yes. Yeah, ML physics. I see this kind of, in English, when you read machine learning physics, it can be the machine which learns physics. It can be physics, which is machine learning physics, and so on and so forth. When we write the algorithms, we cannot afford, and this is the basic thing, algorithm is based on a pure use of rationality. There is no affectivity. The philosopher can tell us clearly that the language of algorithm writing is the language of Wittgenstein, not of the existentialist philosophers, which were contemporaneous with Wittgenstein, but they talked about something completely different. The problem of philosophy, for instance, was always that you can do philosophy, and you have to be rational, and Descartes told us that. But then what about affectivity? Philosophy is something which engages the human being. The same human being who tries to understand the laws of physics, of nature, and he runs into trouble, has to be able to act under the impression of whatever happens to him as a human being. So affectivity, I will use this word because it's a big umbrella word, affectivity. How do you introduce in your thinking affectivity next to rationality, right? And by the way, this history of we need or we don't need to make a hypothesis, you could give anybody who asks you what about the meaning of this or the meaning of that, you can give Laplace's answer to the question when he exposed his cosmology the first time. And I think it was D'Alembert who asked him, but where is God in this story? Kant Laplace cosmology, right? And Laplace said, I don't need this hypothesis. Now, here is a danger with AI. We don't need this, we don't need that. But one thing we certainly need is the rigor and the pure application of those laws of rationality, because otherwise our algorithms will not give us the correct answers. Now, one small observation. So the question of machine learning physics is a good example. We have to be very carefully explain when we talk to people about that, in particular people from outside the field, what that is. What I say always, and I even wanted to make a remark even before this morning, I wrote it down here. I don't have it in my talk as I wrote it down. I made a remark here that we have to say always and to remember always that machine learning means interfacing algorithms with knowledge taken from a specific domain in the beginning when we train this thing. And there are different algorithms to which, if you couple things coming from different fields, economy or, I don't know, architecture or whatever, physics, right? Then you get certain specific answers in those fields. But I always emphasize, I always say that the machine learns to identify patterns and things, right? But the thing is that the predictions made by the machine are based on those patterns which the machine discovered, and there is a large role, there are the statistical probabilities which are used in this interpretation. Okay? And this is very important. All in all, when you put all those things together, I always have the feeling that I lose. And when I'm trying to understand, for instance, I have lots of materials on this field which are written up, and I can send anybody to the proper references. For instance, there are very interesting things which have been done with machine learning in economics recently. And since I heard about this interest here, is we have to be very cautious, because my impression was that after, if I understood correctly what you said at the symposium, I took some notes there, and I think that you mentioned, I think there, that how to map the science, our science and our future. So we will have to clarify this point. If you say that, and if that's the purpose of the group of research which you work with now, then we have to be very careful when we make this statement that we can predict the future. And that is, on one hand, is very good, because if you read about artificial intelligence, this morning I read Japan Times, and there's on a whole page, practically there's no big newspaper or news media who doesn't talk about artificial intelligence nowadays. And people are scared because the news in the Japan Times of today is that there will be trouble with implementing the work which is needed, urgently needed from the point of view of the ecological poisoning of the planet. We have to postpone that probably because AI is taking away a lot of electrical power in the big centers. In America, which has, I don't know, 40% of all the clouds and all the material infrastructure of the business, the consume of electricity is very high, but not only in the States, everywhere. And then we have to go back. You have to go back to fossil fuels, not because the politicians want that, not because the businessmen want that, not because, and so on and so, but it's a reality which may become larger and larger and so on and so forth. So it's good that we make optimistic predictions, but it's dangerous to overemphasize the ability of this machine learning, in particular when we use this syntagm, machine learning, which is clearly ambivalent, okay? It's more than, it's plurivalent. And I hope that in the framework of the collaboration with Professor Suzuki, we will do some work really on the semiology and, of this language, this new way of thinking, which is, and definitely we have to talk about the algorithmic thought. Like I wrote a whole book on what I called at the time disciplinarian thought, and I said, well, the disciplines, we are all coming from different disciplines, right? But in English, what was good, that wouldn't have worked in some of other languages. Disciplinarian means also that it's disciplined. Already you are embarked on a road and you don't go away. If you go away, then you become interdisciplinarian. Now, that's another tricky word, and there were tons of books written about interdisciplinarity, and in the end, when somebody tried to build a theory of the interdisciplinarian thought, a guy in the States, nothing came out of it because you can deconstruct very easily this kind of concepts, and now we have to find a way to be interdisciplinarian because artificial intelligence is a tool. But it's a tool which can be used in different domains. You represent the physics and we do it well. But even as a tool, you can do all kinds of things with this tool. And the tool which your group has chosen is one of the possible tools, whereas in this presentation, the impression is that it is really, if we accept the change of paradigm, or whatever we call it, it's what we have to do, really, in physics. But look, somebody can come and say that there are much more than few sudden, unexpected things. I mean, each time I'm talking to people who are outside the field, they say, what's this matter of dark matter and dark energy? And there are many things more people know about physics. They will ask more fancy questions. If I will come back to Japan and we will have a forum of physicists, I would give a talk about a domain in which, for different reasons from your group, I want to use artificial intelligence. And when did I start?
20 minutes.
10 minutes only? 20. So I'm going to be quick now, because, but I really hope to give this talk. about my field, which was plasma physics. And I got to complexity because I thought I understand what complexity means in science. And for me, as a physicist, and we talked about that, you start with deterministic laws, whether it's Newton or it's Heisenberg, and you avoid, as we learned how to do an integration along a path and how to use all kind of funny concepts. The Greeks didn't want to talk about infinity and about zero because they drive you crazy, right? And then we had imaginary numbers, and then we had to avoid to do all kinds of things in which we couldn't avoid the presence of imaginary numbers, and then we figured out ways. But even so, we had laws. And we built, with these laws, a theory. And we noticed that in any system, no matter what it is, if you have subsystems which are in interaction, doesn't matter what kind of interaction, but obviously they are interacting, then the system is going to go sooner or later to this bifurcation point, and then there will be emergence of something, and there will be this path business, and so on and so forth. So I said, well, we run into trouble even in natural sciences, but I started to think about what is the meaning of complexity outside our comfortable natural science environment. And then I realized that you cannot easily give a definition to interdisciplinarity. There is a lady who spent her entire life at Santa Fe Institute, and this lady wrote a book about complexity. And about at the page 160, page 70, he gives a definition of complexity. And then he talks about artificial intelligence very, very late in this book, which is very important in the context. And she says it straight. It's very hard to give this definition. I gave you a lot of information, and that from there I learned when I'm giving a talk, I never go so structured because you have to prepare the public to what you want to say in the end. The punchlines have to come late, because otherwise they can get to the thing itself. Now, that was a long introduction to say that I very much hope to set up a research program. It has to be international because that's have to have many people working. And when you said also, there are realities in this kind of situation when you try to create a certain research or research activity. Many people, when we do the research, the young people who got tenure in universities, in physics, in philosophy, it doesn't matter what, you do the research at the big research universities, you do them with the graduate students, which are doctoral students. Because there's a master's degree in big and good universities, they do good research, but you still have to have that. So everybody who is on the way up to the professorship has to work extremely hard and cannot afford what we, those who are emeriti, can. I'm coming from Hopkins. I'm an emeritus at the Hebrew University in Jerusalem as well, because I spent my life in between those two universities, Johns Hopkins and the Hebrew University. And in fact, I was hoping to set up this activity with a sort of a symposium where I wanted to invite a number of people who would have been the core of this thing. Unfortunately, the situation being as it is there, and in Europe also, they were, if you look carefully in Europe and in certain countries which are also involved in all kinds of conflicts, there are people who did work in this field, and they cannot go and deal with these things now in person. And I've seen that even at Yokohama. You heard about the big event which took place this summer, in July. You had here the IEEE conference of artificial intelligence in Yokohama. And they gave instructions because many people couldn't attend and had to work. So I wanted to build a core thing, and I will start with people who can spend time indeed, as we, the emeriti, are, and you, the young guys, have to join that, but you have a bit less time and you are embarked in things, and if you want to get a position at the university, you have to perform as the university requires. But in the end, we will try to do, and this explains to some extent why I would give a talk here about, as I started to say, artificial intelligence. Machine learning is important, very important. So here I want to make public this thing. There shouldn't be any misunderstanding. I totally agree with you insofar as the context of what you are doing is concerned. When I said what I said before yesterday, was that I thought that 90% of the people in the public didn't understand what you said. And you were very kind to say, well, you talked to me when you put up these view graphs, and that is true. I will give a talk here about how I failed with trying to continue research started by the only Nobel Prize physicist who dealt with plasma physics, who not only is the only one who got the Nobel Prize for plasma physics, but he's a Swede, Hannes Alfvén. Those who did plasma physics know about the Alfvén ways. And Alfvén didn't believe, wrote an article in 1942, explained his view about a certain type of behavior, which is a result of interaction between electromagnetic fields and ionized particles in this electromagnetic field. So there are currents, there are new, it's an extremely complex situation. So then I started to think about interdisciplinarity and a relation between different domains in the same field of physics. Alfvén tried to offer a plasma universe as alternative to the Big Bang Theory. Can you imagine? In 1989, I was at a conference in San Diego, which a small group, together with Alfvén and another professor from Sweden, Feldhammer is his name, we tried to convince the community, not that the community should accept an alternative to the Big Bang, but to look at the problems, specific problems. You say there are no sudden unexplainables. I mean, the structures, when you go to the structure of the galaxies, when you try to understand what's going on, and we have so many observations now, it's not the dark matter and the dark energy only. There are lots of things which we don't understand and lots of things which we have to try to explain. I came back to Hopkins from San Diego, and I invited, not Alf Wayne, because he was a very elderly gentleman at that point, but I invited a guy from Los Alamos who was doing simulations with a computer power which was at Los Alamos. We tried to simulate all kinds of things, like how do you get the background radiation in the universe from filaments and explosions, local explosions, and in big galactical structures, how do you get this kind of specific structures in certain specific types of galaxies. And the Department of Physics and Astronomy at Hopkins said, no, we cannot afford, because Hopkins is a very big unit in the build of in the world of astrophysics. From my office there, I can see across the street the Space Telescope Institute, and the Webb was built also partly at Hopkins, and so on and so forth. There are this kind of problems also. So you have to break down things to start to build small groups. And I want, for instance, with artificial intelligence, and here I will stop this kind of general remarks, in order to say a few words about this reflexivity. But the point is that I would ask questions. First of all, I want to use AI, the ML plasma. There will be such a thing. And we want to go back specifically to this kind of problems and see indeed what we can do now and what we can extract from artificial intelligence. It's also a kind of inverse engineering which we apply with artificial intelligence, and that's what I'm curious about. Also, I'm going to discuss with Professor Suzuki another thing which is very important for this phase of what you said. There's a whole discussion in the early quantum mechanics about between all the heroes of the early quantum mechanics, right? Niels Bohr, and how the discussions with Heisenberg and so on and so forth, lots of things, in which they tried to, they oscillated. And the Gedanken experiment, what is the translation in Japanese of the Gedanken experiment? Einstein's Gedanken experiment, which took him from the restricted relativity to the general relativity. I want to try to see if we can use AI to figure out the relationship between, in fact, between AI and the concept of this Gedanken experiment is a thought experiment, right? That's how that's in English, but I don't know how familiar you are with this in Japan, but in Europe.
But we had one.
Yeah, well, but in Europe, everybody was talking about that, and that is extremely important. Now, what is that? What is that, really? This is a natural way of intelligence, of course. It's something which maybe artificial intelligence can pick up. And I want to start with a few well-known Gedanken experiments in physics, and not only in physics, and then let's analyze with something similar with ChatGPT. I'm not so infatuated with ChatGPT, but I agree that it's very performing. And then to see how can we figure out subtleties like that in view of analyzing this new algorithmic thought. And here I stop because that manages to take out all my time. How much do I have yet?
5 minutes.
How much?
5.
5 minutes. Now listen. Why did I, how, I guess, I don't know if Professor Suzuki had a chance to explain to some of you so far, probably you will do it today a little bit about the reflexive thought. Reflexivity, to me, seems that is almost synonymous in our context to philosophy. So if you would accept that this is a good tool to look at the things, then I would, it's very important to really go to reflexivity as a way of thinking. And I found somewhere, I don't know where, on the internet, just to define indeed for everybody this thing. If you go to Google, then you read a silly definition. Reflexivity is about acknowledging your role in the research. So I, as a human being, I'm involved in my research. Well, it's a subtle thing, but it sounds a little bit silly, as it is said here. As a qualitative researcher, you are part of the research process, and your prior experiences, assumptions, and beliefs will influence the research process. Okay? Now, look at this ambiguity again. What does it mean, qualitative researcher? So for a physicist, a qualitative researcher is somebody who cannot use mathematics, cannot quantify. It's not that he's qualified in his field, but it's a field, indeed. Philosophy is a qualitative research, really. But then why call this reflexivity? Because that can be philosophy, and I don't need another definition. So I was puzzled by this thing. And when in our correspondence you wrote me about your interest in that, I said, well, after this simple, I'm going fast now, qualitative research is certainly a good metaphor for humanistic research, and the creative thinking, here I'm trying to avoid change of paradigm. For me, it's creative thinking, it's easier, is what characterized the last decades of the 19th, and here now I'm talking to this thing which you mentioned here, without having seen that at the time I wrote this. Creative thinking is what characterized the last decades of the 19th and the first 30 years of the 20th century physics. From Mach, Planck, and Boltzmann till Niels Bohr, Albert Einstein and Werner Heisenberg, all were dominated by reflexive thought. While Ludwig Boltzmann said in 1904 that we must not aspire to derive nature from our concepts, but must adopt the later to the former. So apparently Boltzmann wasn't so crazy, because he said something very simple. Look at what's happening and then introduce rules and so on, as we did. Einstein took the opposite view. He criticized Mach because he considered that science consists merely of putting experimental results in order, not recognizing the free constructive element in the creation of a concept. he thought that somehow theories arrive by means of discovery, and not by means of invention. This is, Einstein wrote explicitly that in a letter to a friend of his. So you will have to explain that in your talk, Professor Suzuki, because I wrote here something about was this and that philosopher have a discourse based on Entdeckung versus Erfindung. Invention, what I just said in English before. Now, even in hard science, the greatest mathematician of the first part of the last century was Poincaré in France. And philosophy guided entirely his mathematics. And that is well documented. He wrote about that and he explained why and how. And Einstein realized the necessity for mutual interaction between philosophy and science. That's what I read this in order to say that. Now, in the 2.5 minutes which I still have, I have here something, but I will just say the following. How many of everybody who is here had heard about the Sokal affair?
ソーカル事件について知ってる人。ソーカル事件。
Okay. So 1, 2, 3, 4. This is the danger in our interactions. Sokal is a physicist. He's a guy from the NYU who have another very good friend, Bricmont, who is a Belgian fellow. And Sokal got fed up by all kinds of things he heard around him about this postmodern deconstructionism. And he, as a physicist, couldn't understand how can people talk that way, and what are they talking about. And there is a danger, because if you are just a fantastic equation solver and you learn the intricacies of the mathematical apparatus and the physical subtleties, then you can go on, and as Laplace said, you don't need all kind of things like that. But Sokal said, you know what? All these guys have no idea what they are talking about. And then he wrote this fantastic text, 25 pages or so of total nonsense, using totally correct syntax and notions taken from modern physics. But it went to high-energy physics as well. Both Sokal and Bricmont are involved in high-energy physics. So, and sent it to the most prestigious American journal, Social Text. And this article was published as it was. I was stunned how he dared do that, and what I was waiting to see what will be the follow-up of something like that. And the community called it Sokal's hoax. Okay, so it was a hoax. It was disgusting, said everybody in the humanistic world. How could he do something like that? But at the real point is that he could do it. Now, when Max Planck got the article of Einstein in 1905, And Einstein was a little guy working in this office for patents. And he sent it to the best physical journal in Germany. Nobody knew what the hell to do with this thing, and they gave it to Planck. And Planck read it. He immediately understood what it was of value in this thing, and he said, yeah, we publish it. No referees, no review, nothing. Max Planck said, it's okay, it's okay. So, but today we live in a world where we have to be very careful with what we are saying, and we have to be very careful not to fall into the pitfall of the hubris. Hubris being overestimating our capacities, and we can say, well, they don't know about what they are talking, and we know. They say, well, these guys talk a language which we don't understand, but we have to work together. And that is very important. And that is why I now will not have the time to read you what I wrote here about reflexivity, but take very seriously this thing, because it's very, there is here a story. Maybe I can take this text and somehow give it to you, and you give it to the people who were here, or anybody who wants, because it's very instructive. And just one sentence. A professor at that time at UCLA, who became very well known in this domain of artificial intelligence, the borderline between humanities and science. Catherine Hales, maybe some of you know the name. She was at UCLA. After that, she's now Emeritus from Duke University, so it's a personality in this world. And she told a story about how she tried a program like what we try to do here, and with this I will finish. Catherine Hales says in the preface to a book, so everybody can read that, that she tried to put up a group which was a physicist herself, and I don't know who was the third one. Now I don't have the patience to read all this. Just want to tell you what she says. The physicist led us through Gödel's incompleteness theorem to show how reflexivity, and that is why I took this thing, entered into mathematics and physics. The philosopher guided us through Aristotle, Kant, Fichte, and others to trace the roots of reflexivity in the philosophical tradition. I, Catherine Hales, added readings from Borges, Hofstadter, and Calvino, Italo Calvino. Despite our best efforts, our stated goal of illuminating the expansive range and importance of reflexivity in a variety of fields certainly fell short of its mark. If we want to build a program interdisciplinary and bring together the best in hard sciences with the best in humanities, we have to keep in mind this warning. Because if we will fall short of that, we won't succeed, no matter how international this thing is. And now, just to show you, here I have a conference for, I don't know, three hours or something like that. And there are many subtitles here which are very important, and we should discuss them, but hopefully we will be able to put together a group and start doing things. Practically, I hope we have to move on. in 2025, we have to establish this group. And in 26, the next IEEE conference, which was held at Yokohama. Look up this thing on the internet, and you will see all the Japanese heroes of the domain who your newspapers, I've seen an article from Masahi after the Nobel Prizes and all this dispute why Japan was not recognized, because there were 4 of the main names in Japan in this field have been this summer at this conference. I will give you the names, and with this I'm finished, just to look them up and to see how serious this thing is. And what I hope is that a group, first in between Kyoto and Hopkins in the States, and later on we will have to be in Europe as well, this will participate at the next conference in 2026. If we got there, then we are in good shape. I don't think I have the names on this. I don't remember where I put. Here it is. Is Kunihiko Fukushima is one of the 4. Of course, Professor Amari, which we discussed about. Shiro Takauchi and Hiroshi Yamakawa. All of them were in July at this big international conference, and the organizers of the conference said that they are the pillars on which the business of artificial intelligence relies in Japan. Thank you for your patience. And I'm sorry that, again, it took me too long, but we have 2 short sessions. We will have to have some ways, I don't know exactly how, but with the internet we can continue the discussion, and we have to focus, and we have to be careful not to do too many mistakes. Mistakes we will always do.
Okay, Professor Finkenthal, thank you very much.
Thank you.
So as a chairman, I need to keep time, but I have too many questions about yes. So let me have a few minutes discussion session and then go to the break. Yes. So my question will be later, but if Professor Otsuka or Professor Suzuki, do you have a question?
Thank you very much for the encouraged presentation and your concept of reflectivity. It's so many opportunities to average the machine learning or the thinking style of philosophers and so. And I find the new definition of reflectivity is unique. And I think this new paradigm of reflectivity is needed. What do you think?
Yeah, I think that reflexivity should become, maybe we should change the name, because if many people use it in so many different ways, or maybe we should focus on a definition which is very clear from the very beginning. But for me, as more I think about that, it has to be a guiding way or an important component in this discussion about what I want, and I repeat it, the algorithmic thought. And when I said we should write also, I told you, a metaphysics of the artificial intelligence. And I said, well, you in Japan have a good reason for that. I mentioned Nishida. Now, in my computer, I left the computer luckily at the hotel because I didn't know that my hotel is so far away from this place, and it was very hot outside. And I did well that I didn't bring the computer. In the computer, you will give me your email now, of course, and I will send you, I extracted a few things about Nishida's metaphysics. And Nishida's metaphysics, we don't have to be, again, this is something physicists don't like. What is metaphysics? We don't need metaphysics, we do physics, right? But when you talk about what you do, you have to talk in certain ways. And meta means in Greek, beyond physics. So meta, the word metaphysics, there were lots of things. I tried to read a little bit about what's going on now in metaphysics. If somebody is doing metaphysics today, found a lot of material. And sometimes I threw away the book after I read a couple of phrases because indeed there seemed to be a metaphysics which is passé. But not everything is passé because it was invented, I don't know when. We will hear about that after the pause. Again, thanks for your patience, and we'll continue the discussion.
So thank you very much. Let's thank Professor Finkenthal.